Super exciting. Libghostty now supports the Kitty graphics protocol. Of course, Ghostly itself has supported the Kitty graphics protocol since version 1.0, but we were blocked on some things from exposing it to Libghostty, but that's now all fixed. I'm going to show you how it's all fixed. This is super exciting because I think that Libghostty might be the first embeddable terminal that supports the Kitty graphics protocol. If not the first, one of the first. I don't want to like make that claim. I didn't look too closely, but let me show you it working. I updated Ghostling with Kitty graphics protocol support. So if we use Kitty's iCat image cat tool, we can now see that it works. Ignore all the output back here. The way the rendering is implemented in Ghostling is pretty inefficient, but Libghostty itself is pretty good. Now let's take a look at like the changes that were required. So here's the Ghostling PR that made it all happen. It's only about 270 lines of code. And let me show you what we exactly changed here to make it work. Let's start from the bottom, right around here. So the first issue that was holding back the Kitty Graphs protocol is the Kitty Graphs protocol supports PNGs. And I didn't want Libghostty has no runtime dependencies other than libc or libc++, only if you use SIMD. If you don't use the SIMD features, it actually has no runtime dependencies whatsoever. It's fully freestanding. So I didn't want to introduce any new dependencies at all to this. And I came up with this approach, which is the sys interface. And let me see if we actually have, yeah, we have a doc for it here. Let me zoom in. On the Libghostty docs type, we have the system interface now. And this is an interface that lets us have runtime swappable sort of function pointers for operations. And the whole point of this was that Ghostly itself should operate with no dependencies. But if you can bring along some dependencies, then we could support more features. And since it's runtime swappable, you could bring along the dependencies that make sense for your ecosystem. So for example, the Rust Libghostty library or implementers can use a Rust PNG decoder. Go could use the built-in image/PNG decoder, things like that. Like it's so much easier to do that than to bring along a whole new C dependency, which comes with all the downsides of a C dependency. So the only one we support right now is the PNG decoding callback. So you're able to set that up. Let me show you what this looks like. Here's what the callback looks like. Basically, Ghostly at any point for any reason could call into this if it's set with the PNG data and it expects an image out, which is the decoded image out. If you set this, we could do PNG decoding. So that's one of the things we did. If you don't set this, the Kitty Graphs protocol will still work. It just won't support PNG files. But the Kitty Graphs protocol supports direct RGB and things like that, and it'll work in that case. So this is pretty cool in that it's totally optional. In the Ghostling case, I was able to set this up, and since we're using Raylib, we could use Raylib's API, PNG APIs in order to do all the decoding. So you can see how this brings along your own dependencies, which is super cool. So let's go back here. And the next thing is we expose the Kitty configurations out of Libghostty. So by default, Ghostly only supports, I think it's a 10 megabyte total limit of all images in Kitty. The Ghostly GUI supports significantly more, but for the embedded case, I made it much smaller. So the first thing I do here is increase that to 64 megabytes by doing that. And then again, by default, we're trying to be conservative with Libghostty, so we don't want to surprise anyone. So Libghostty will not support any file-based or shared memory-based transfers. We don't want Libghostty to do any file system access without you knowing. And so you have to opt in to enabling the various file mediums. Again, if you don't enable these, the Kitty graphics protocol still works because the graphics protocol supports something called I think it's called direct, the direct medium, where the bytes for the image are sent directly over the PTY. And so we could support the direct medium with no PNG decoding with a 10 megabyte limit out of the box, and that's all going to work. But in Ghostling's case, I enabled all of it. And then on top of that, we had to implement a whole new sort of iteration API so that you could actually read the state out of it. And that's what's happening here, more or less, in the render Kitty images. So there's now a full API. Actually, let me see if I put it out anywhere. Yeah, here it is. Here's the PR that introduced it. Here's all the different C APIs that were introduced and C types that were introduced in order to read data out of it. So here's an example of getting the Kitty graphics data out of your terminal. So that reads it out of the terminal. Then we create an iterator to go over all the placements. Placements are what Kitty graphics calls images that are like have a location to render on the screen. And then we iterate over them. And for each placement, we get the image ID, look that image up, and we could get information out of it: the width, the height, the format. We print it out. We could print out some computed sizes, how many pixels it's going to take, how many grid cells it's going to take up, things like that. And then by using this API, you could actually build a renderer, which is what's happening here. You can kind of see the same shape, iterate over placements. Ultimately, we'll skip all the details, but ultimately, this creates an image type for Raylib, sends that into a texture, and then does the draw. And so this is how the actual image gets drawn. But let's see if there's anything I missed here. No, these are all PRs that just add more APIs to make this work. But this is now available to both the Go and the C interface. C obviously has much better documentation because it has Doxygen, which is pretty stable. So you could go look at Kitty graphics live right now, and there's some docs on how to do stuff. There's also an example. There's actually a full example in the repository showing you how to read stuff about the read out the state of the Kitty graphics. But yeah, this is super exciting. Now anybody that's embedding Libghostty could get full graphics protocol support very easily. And like I said, I don't think there's any other like highly portable embeddable terminal that actually supports Kitty graphics. And I think even like Xterm.js, that was the one I looked up. I think Xterm.js just got support this year, a few months ago, which is awesome, by the way. Like, I'm really happy for that because that means that VS Code and other things get it. But the point is that it's rather minimal, and this is really going to help grow the protocol adoption. It's the best way to do graphics in a terminal, and so yeah, wanted to share this really exciting update, and hope to see more graphics in the terminal because of it.